So this is what we were just looking at, right? Intersecting lines with one solution that's consistent and independent. Same line, infinitely many solutions that's consistent and dependent. Inconsistent, parallel lines, no solution. So substitution method. This is the first algebraic method to solve systems of equations. What you do here is you solve for one of the two variables. Then you plug in what you just solved into the second equation for that variable, and then solve what you have remaining for the remaining variable. And then, whatever you get for that remaining variable, you plug back into either of the first two equations and solve for the other variable. So here is an example of that. So Lancaster Woodworkers Furniture Store builds two types of wooden outdoor chairs. A rocking chair sells for $265, and an Adirondack chair with footstool sells for $320. The books show that last month the business earned $13,930 for the 48 outdoor chairs sold. How many of each chair were sold? So we need to come up with our equations from this word problem. So we know that they had rocking and Adirondack, and we know that they sold 48 total chairs. So rocking plus Adirondack equals 48 chairs. We also know that they sold $13,930 worth of them. So we know that the rocking chairs are $265 and the Adirondack are $320. $13,930. So there's our two equations with two unknowns. So the first one, we want to solve for either one. It doesn't matter which one. So we're going to subtract the r from it. So we end up with a equal to 48 minus r. So now what we're going to do is take that, a little bit we just came up with, 48 minus r, and plug it in for a in the second equation. So we now have 265r plus 320 times 48 minus r equal to 13,930. So that means we now have an equation with one variable. We just need to simplify. So we need to distribute the 320 into the parentheses. So 265r plus 320 times 48 is 15,360 minus 320r equal to 13,930. Need to combine like terms, so we got the positive 265r and negative 320r. When you subtract that, you get a negative 55r plus 15,360 equal to 13,930. And now we're going to subtract 15,360 from both sides. Eliminating it from the left. And we now have negative 55r equal to a negative 1,430. And we need to just divide by negative 55. So we are now left with our r value of 26. Rocking chairs. So now we know what r is, we want to find what a is too. And we already have an equation, we just made it, that solves for a. So our a value is going to be 48 minus 26. Or just 22. So they sold 26 rocking chairs and 22 Adirondack chairs. So that was the substitution method. Now the elimination method does exactly what it says, right? Substituting elimination method is going to eliminate things. So what we want to do is make sure that we have coefficients that we can eliminate either using addition or subtraction. And then once that happens, that will eliminate one of the variables, leaving us with one variable remaining. solve for that one remaining variable, take that, plug it back into the original two equations, either one, and solve for the other variable. So here we have two that are pretty simple. And really, since we already have x, both of them with a 1 coefficient, we can just subtract right away. So when we subtract, the x's will eliminate because x minus x is 0. 2y minus y is going to be just 1y. And 10 minus 6 is 4. And there's y. Pretty simple. Elimination is not always as simple, by the way. But in this case, it's working out that way. And then we're going to plug it back into either of our two equations. Since the second one is the simplest, we're going to use that. So x plus our y value, we just got a 4, equal to 6. We subtract 4 from both sides. And x equals 2. So our solution here is at the point 2, 4. This one was pretty simple, and there are simpler methods or examples of substitution. We just didn't do one earlier. There are also more complicated elimination problems that we won't look at right now either. But these are all the different ways you could solve these systems of equations. Tables, graphs, substitution, elimination are the main methods. Graphing and tables work when you don't have decimal solutions. Substitution, elimination will get those for you. But substitution is best whenever you already have x or y already set by itself without any coefficient, or the coefficient is just 1 or negative 1. Elimination is great whenever they have either opposite or same coefficients, just depending on which one it is. You use either addition or subtraction. And multiplication, you have to multiply one or both of the equations by some other number to get those opposite or same coefficients to add or subtract them. And so now we're going to shift gears and take a look at solving systems of inequalities. This is just like solving inequalities before. You graph it and then shade. But in this case, we're going to graph and shade two lines. Where it overlaps between the two lines, that's your solution. So here we have to graph these two. They're already in slope-intercept form, so it's ready to go. So the first one, y is greater than or equal to 2x minus 3. So our y-intercept is negative 3. Our slope is 2, so we're going to go up 2 to the right 1. And down 2 to the left 1. It is greater than or equal to, so it's a solid line. And greater than just means we're going to shade above it, but I'm going to wait to shade for now. Shade for now. For the second one, our y-intercept is positive 2. Slope is negative 1, so we're going to go down 1 to the right 1. And up to the left 1. This one is just less than, so it's a dotted or dashed, however you want to write it, line. So like that. And this one's less than, so it's going to shade below. So now I'm ready to go ahead and shade. For the red line, I'm shading above it, but I'm not including that dotted line. For the blue line, I need to shade everything below it. And I can include that solid red line for this one. So really, our solution, I'm shading in purple now, is everything over to the left there in purple, and including that red line that's below the dotted line. And that is how you solve systems of inequalities. There's really nothing to write out aside from graphing them. So now I want you guys to try one.